Hey everybody, this is Matt with Camping and Coding. I have decided to do a series on the LeetCode 75 problems because despite being a professional software engineer in big tech and having many years of experience, I have felt that my fundamentals are getting sloppy, largely I think thanks to AI and my willingness to offload a lot of the cognitive burden to AI in my professional life. So I want to correct that, and I think it would be fun to go through the LeetCode 75 and just kind of freshen up my basics a little bit. Okay, so we're going to start with the very first problem, which is merge strings alternately. You were given two strings, word 1, word 2. Merge the strings by adding letters in alternating order, starting with word 1. If a string is longer than the other, append the additional letters onto the end of the merged string. Return the merged string. Okay. Here are some examples. Typically when I read these problems, I don't understand the question as it's written on the first read through, so I will take a look at the examples and it helps me understand. Jumps out to me here that these words don't have to be the same length, which is useful information to have. And then I look at the constraints. So we don't have to worry about empty strings because one is less than or equal to the length of both strings, and they're only 100 characters long. And they consist of lowercase English letters only. Okay, so this is pretty clearly a pointer problem, and I don't mean pointers in the C++ sense, rather pointers just that allow us to index into the strings. So we're writing this in Python. This should be pretty straightforward. One thing to know about Python is that strings are immutable, which means you cannot change the string. So we'll need some kind of merged string output. So let's call that merged. Just make it empty. Okay, and so we'll need one pointer to keep track of where we are in word 1 as we merge, and another to keep track of where we are in word 2 as we merge. So let's call it word 1 pointer. It's the very first character, word 2 pointer. These are long variable names. You'll see in some solutions where they do something like W1 or whatever. I like to have longer variable names. I found just in real professional software engineering, it's typically better to have longer variable names that are more descriptive than 1 or 2 character variable names that are confusing, and especially as program sizes grow, it can become very confusing. Okay, so our algorithm here is just going to be that while our pointers have not reached the end of each word, alternately add one character from each word to the end of merged. There are, I suppose, a few ways to do this. The way that I want to do it is to iterate over both of the words at the same time, append the correct character from each word, starting with word 1 and then word 2 to our merged output string. And then once I've reached the end of one of the words, or both, we'll need to do some checking to make sure that we have in fact reached the end of both strings, of both words. So we're going to say, while word 1 pointer is less than the length of word 1, so while we haven't reached the end of word 1, and while word 2 pointer is less than the length of word 2, so while we also have not reached the end of word 2, merged is just going to be word 1 at our current word 1 pointer location plus word 2 at our current word 2 pointer location. Okay, and then we need to make sure we increment both of these. Okay, so that's our very basic case. And then we're going to return the merge string. So let's see if this will work. Just a spoiler, it won't. Right, and so it fails as expected on the case where the words are not the same length. It passed fine on the case where the words were the same length. Okay, so we need to know, are we at the end of the first word? Are we at the end of the second word? If we haven't reached the end of one of those words, we need to append the rest of the characters in that word to our merged string. So I'm just going to check word 1 first and then word 2. Doesn't matter. It's guaranteed to only be one of them, but this is neat. So word 1 pointer is less than length of word 1 merged plus equals word 1. If you're not familiar with Python string slicing syntax, in general, it is just, so you have some string s, you can index into it and extract a chunk of it by saying, this is the first index of the chunk that I want, and this is the first index past the end of the chunk that I want. So this would get the characters at index 1, 2, 3, and 4, but not 5. So it's an exclusive range here. Okay, and if you just have a colon with no index at the end, then it just goes to the end of the string. Okay, so that's what we want. Else, if word 2 pointer is less than the length of word 2, and like I said, we're guaranteed for exactly one of these to be the case, so we don't really need to say elif here, but there's no reason not to. Word 2 pointer to the end. Okay, so let's try this again. Passes those. Let's create a couple more test cases. Let's do just a single character as word 1, a single character as word 2, and then let's do a case where we have a single character in both, just for funsies to see if we're covering some of the edge cases here, which we are. Let's submit it and see what LeetCode thinks our runtime is. That's nice. LeetCode thinks we're very fast and very efficient with memory. Now, I will caution you, if you're new to LeetCode, or maybe even if you're not and you just didn't know this, LeetCode is super unreliable when it comes to runtime and memory usage. So, and that's just because, there's a lot of reasons. One of them is that it depends on their compute. It also depends on the language that you're using a little bit. It also depends just on kind of internal, call it jitter, just kind of inconsistencies with the actual computation of the program and compilation and execution of the program, not necessarily anything about your code. So what's really important to understand about runtime and space complexity, or what's really important about those, is that you can explain it and understand your own space and time complexity from the code itself. So take a second to try and figure out what you think our space and time complexities are asymptotically here. So that would be big O of what? I'll give you a second. Okay, welcome back. So our runtime complexity is big O of n. That means we're linear with respect to the input size, which in this case is the length of word 1 and plus the length of word 2. And that's because we are just iterating over each word exactly once. Space complexity here is also linear with respect to the input. That's because we're creating this merged output string that is equal to the length of word 1 plus the length of word 2. So big O of n in terms of space and time. Okay, I hope that was helpful, and I'll see you here next time for the next video and the next problem. Thanks, bye.